Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are looking at a typical exam sum related to the Doppler effect. Now this sum here was found in the November 2010 paper. So in the November 2010 paper, this is the question that they had. Now let's look carefully at this sum. The siren of a burglar alarm system has a frequency of 960 Hz. So if we look at this, we must decide now, is this the source or the listener? So the siren is the one that makes the sound. So this is the frequency of the source. And the Hertz will tell you that it's frequency. During a patrol, a security officer traveling in his car hears the siren of the alarm of a house and approaches the house at a constant velocity. The detector in his car, detector means listen. Detector means listen. In his car registers the frequency of the sound as 1000 Hertz. So the frequency of the listener is given by 1000 Hertz. Name the phenomenon that describes the change in the observed frequency, obviously the Doppler effect. Now, if you look at 6.2, this is where the question is calculate the speed at which the patrol car approaches. So the patrol car is the velocity of the source. Sorry, not the source, the velocity of the listener, because the patrol car listens. So the velocity of the listener, the patrol car is the listener. Because as we said here, the security officer listens to the sound that's coming from the home. So the burglar alarm is the source, and the security officer in this car is the listener. So the car is the listener. Use the speed of sound in A as 340 Hertz. So to begin, we must write the Doppler equation, which says FL is equals to V plus minus V listener, all of a V plus minus Vs Fs. And if you look at this, the frequency of the listener, the frequency of the listener is 1000 Hertz. So we got this here, it's 1000 Hertz is equals to, the V is the speed of sound, which in this case is given as 340. And because it's moving towards, if you're moving towards, the top must be plus and the bottom must be minus. So 340 plus minus, the listener is moving towards, and we are asked to calculate the speed of the listener. Calculate the speed at which the patrol car approaches the house. So we must look at the speed of the listener. So VL is what we must find. All of a V, which is 340, minus the source is standing still, the house is not moving, and the frequency of the source is this frequency of the alarm system, which we saw here as 960 Hertz. Now that we have all that information, we can calculate the answer. So if we multiply this out, we get 1000 multiplied by 340, which gives us 340,000 is equals to 960 multiplied by 340 plus 960 VL. And if you do this, we get, and we take this onto the other side, I'm just short-circuiting it a little bit, 340,000 minus 960 times 340 will give you 326,400 is equals to 960 VL. There's different ways of calculating this. Don't forget here on the top, I didn't put this here, but it is good to put your data because you need your units. And what will also help is to use a diagram. Don't forget if you're not sure of how to do these sums. But continuing here with the maths, we see 340,000 minus 326,400 will give you 13,600 is equals to 960 VL, and if you divide both sides by 960, see that we can work out the velocity of the listener, which will be 14,17 meters a second. So that's a typical way of doing the sum. Now, if you look at 6.3, it says if the patrol car had approached the house at the highest speed, how would the detect frequency have compared to the first observed frequency of a 1000 hertz? Right or down only higher than, lower than, or equal to. So if you are approaching at the higher speed, basically you will receive the wave crest at a higher rate. So the frequency, because it will be greater, you will receive them quicker. The frequency will be higher then. So this is a typical question that you could get in an exam, and I hope you've paid careful attention and worked with your pens and pencils. And this is an easy way in which you can answer questions related to the Doppler effect. Thank you very much for listening.